Hey guys, so today we'll be starting topic 6, compounds and chemical reactions, and basically we'll be doing the periodic table of elements today. It's really easy, and although there's 5 activities, I'll be doing one of them with you as an overview of what's going to happen in this topic, and the last 2 of them is basically just memorizing the first 20 elements of the periodic table. So no stress, it's going to be really easy, and yes, welcome to NS Term 2. Okay guys, so activity 1 represents a chemical reaction on page 75. It's basically the activity that gives you an overview of what the topic is about and the main concepts that you'll be covering in your topic, such as chemical formulas, the periodic table, all of the elements, and chemical equations, and the symbols and the formulas. And that I just read from the questions because it's the main important things in this topic. And all of the subheadings within the topic. So it gets really easy if you know all of the definitions of like a chemical formula, what is the periodic table, what are elements, and the types of elements like metals, non-metals, or in between ones, and then the symbols and the formula. And it gets easier as we go on because we'll be going through this more in depth later on in the topic. But for now, let's just do the activity to see what we know of chemical reactions so far. Okay, so question 1 is write down the chemical formula of water. And we know that a chemical formula is basically writing down the elements within a compound using their symbol. So if we have hydrogen and oxygen, that's water, right? And together it makes the compound water, and the chemical formula for that would be H2O. H subscript 2 and O. So that is as simple as that is for the chemical formula of water. Then question 2. Will you find the chemical formula of water in the periodic table? Explain your answer. Well, no, we won't, number 1. And because, let me just write because as nicely as I can. The periodic table doesn't contain compounds, it only contains elements. So yeah, hydrogen is in the periodic table and oxygen is in the periodic table. But at the end of the day, what we need to remember is that this is a compound. This boy is a compound. And because it's a compound, it will not be on the periodic table like that. So we can say because H2O is a compound, and the periodic table, which is PT, I'm just going to label that PT because I'm not going to write it all out, only contains elements. And that's really easy. If you just remember the properties and the way in which the periodic table acts, then you will know that H2O is not in the periodic table, but only the H or only the O is in the periodic table. Really simple. So question 3 is name the 2 elements that join to form water. Well, we have H2O for question 1, so you can just look at question 1 and see, okay, well, we have H and we have O. And what is H? That is hydrogen, the first element in the periodic table, and then of course oxygen. Okay, now question 4, are the 2 elements in question 3 metals or non-metals? Now firstly, we need to ask ourselves, what are metals and what are non-metals? So we know that metals are all solids at room temperature, and room temperature is 25 degrees Celsius. Okay, so that is for metals. Metals are solids. And we know, okay, water is obviously not a solid unless it is below 0 degrees. Okay, so that's for H2O. Okay, and then it is a solid, and we call it ice. But we know that at 25 degrees Celsius, water is a liquid. And that means it's not a solid. Obviously, it's one of the phases and it's a liquid then, and we just call that normal water, okay? So it's definitely not a metal because it's not 25 degrees. I mean, it's not a solid at 25 degrees Celsius. Okay, so we can go ahead and say it's a non-metal also because non-metals are mostly gases and mostly solids at 25 degrees. Now, I know that water is a liquid, but we need to remember that water is a compound of H and O. And both these guys are gases at room temperature. So when they combine, they make a liquid. But the important part is that are the two elements, they are referring to the elements separately. In question 3, metals or non-metals. So we can say they are non-metals. Also, it can be really easy if you look at your periodic table. You'll see that it shows you the sections that are metals, the sections that are non-metals, and the sections that are semi-metals. That makes it really easy to identify whether or not it's a metal or a non-metal, but that is just the hard way to think about it, the way in which I just explained it to you. But it's okay. Either way, doesn't matter how you find it. If you don't have the thing that shows you which are metals and which are non-metals, or you don't have the knowledge about that, you can always think about the elements, whether them being metals or non-metals, in this way. Okay, question 5. Write a chemical equation to represent the reaction between hydrogen and oxygen using symbols and formula. So firstly, symbols, we know, okay, in your periodic table, here's your hydrogen and there's your oxygen. And that's what your elements look like, except they have their atomic mass and atomic numbers. And I'm not sure about oxygen, but basically that's what hydrogen looks like. So when it says write the chemical equation to represent the reaction between hydrogen and oxygen using symbols and formula, you're going to use these guys together and write your little equation for the reaction of water. And we can already just write, okay, H2O is at the end here. But what happens here? What gets added together? Well, we know it's H and O. But in what ratio? Because remember, from grade 8, a chemical equation is a ratio of two elements added together to form another ratio of them as a compound. Now the thing about H and O is that they are diatomic molecules. I'm going to write that here, diatomic. I hope I spelled that right, diatomic molecules. Which means they can't just stand like H on its own or O on its own. It means there are H2 and O2. And that is how you write them. That's a standard way of writing those guys because they are diatomic molecules. And you'll learn more about diatomic molecules later on, or maybe in grade 10. But basically, there's a bunch of them and you need to know them off by heart in order to do these things. But it's okay for now. You don't need to know them just yet. But we can see that our little equation that we have so far is not balanced yet because we have two oxygens over here and we only have one oxygen on this side of the equation. So we need to balance that, and the way in which we do that is we write a 2 in front of the H2O on the right side of the equation. But now we have 4 hydrogens, and the way in which we know that is the 2 in front of the H2 times with the subscript 2, and that means there are 4 H2Os, and now there are 2 oxygens, okay? So basically, on the left side of the equation, we have 2 hydrogens, and we would want to put a 2 in front of those guys so we can have 4 here. And because we have 4 hydrogens on the left side and 4 hydrogens on the right side, the hydrogens are balanced. And we also have 2 oxygens on the left side, as you can see over here, and 2 oxygens on the right side, which means the whole equation is now balanced. And that's basically how you do this activity. I know it looks like a lot of scribbles and stuff, but it's okay, you'll get through it. And I'll be moving on to the next slide now. Okay guys, so now we're going to start Unit 1, which is the periodic table of elements. This is really easy, like I say, for nearly everything. But let's just get to it. Representing elements in the periodic table. So if you look in the corner of the periodic table here, they have boron in large, but I'm just gonna write it down here, make it a little bigger so we can see what is happening. So boron, the atomic number is 5, and the atomic mass is 11. Okay, so atom number and then atom mass. Cool. Now, the atomic number is basically the number of protons in the nucleus. So we know that boron has 5 protons in the nucleus, okay? But the atomic number is also the number of electrons spinning around the nucleus. So we know that, okay, boron also has 5 electrons. Oof, let me just get that in there. Okay, now the mass number is 11, okay? 11, I'm just gonna write it over here, 11. And we know that the number of protons and the neutrons in the nucleus is the mass number. So if we look at this little formula, it says the mass number is equal to the protons plus the neutrons. Now we don't know what the amount of neutrons is in boron yet, so we're going to figure that out using this formula. So firstly we're going to write the mass number, which is 11, is equal to the protons, and we know that there's 5 protons plus neutrons. Now this is easy, we're just going to take the 5 to the other side, and because the 5 is a positive number on the right side of the equation, it'll be a negative number on the left side of the equation. So we can write 11 minus 5 is equal to the neutrons. And hence we have 6 neutrons. I'm just writing that over there. So we know that there's 6 neutrons in boron. Now also it says that the mass number minus the atomic number is the number of neutrons in the nucleus. We could have also figured out this way, but we basically just did that, but I'm going to go through it in any way. So the neutrons in the nucleus, again, we don't know what that is, let's just pretend, is equal to the mass number, and the mass number is 11 minus the atomic number, and the atomic number is 5. So as you can see, there's 2 ways of figuring this out. You can use either way, but in this case, I'm showing you both ways. You can just decide what you prefer. And I would say using this formula that we're doing currently, because you don't have to take anything to the other side of the equation and change the subject of the formula, nothing like that. So use this one if it's easier for you. So 11 minus 5 is 6 again. And we have the same answer, which means that both formulas are correct. Cool. That is representing the elements in the periodic table. As you can see, on all of the elements, there's always going to be a little atomic number and mass number. Same for lithium, beryllium, magnesium, potassium, calcium. Every single one of them will always show you the atomic number or the mass number. And it's really nice, you can get this in your test, like you get the periodic table in your test. So if they tell you, oh, look at a hydrogen and tell us what the how many protons there is in hydrogen, you'll know that it's 1 because the atomic number is the protons, right? And the atomic number for hydrogen is 1. So it gets really simple, and you will need to learn your elements off by heart basically to be able to do this, because hydrogen is H and lithium is Li, but you don't get a periodic table like this in the exam that tells you, oh, Be is beryllium, you know. So that's going to be the last 2 activities for you, teaching you to memorize the first 20 elements in the periodic table, which will be very useful for you throughout the rest of this term and your end of year exams. Cool guys, next slide. So now we have 2 more examples for representing elements in the periodic table. Example 1 is hydrogen, and I'm going to draw that here because it was on the previous slide in the thing. It's just H here. The atomic number is 1 and the atomic mass is also 1. And here in the example it says hydrogen, the chemical symbol is H. So just remember that this thing is the chemical symbol. And it says here, okay, well, the atomic number is 1, and we already wrote that down here, which means it's the first element. It has 1 proton in its nucleus and 1 electron spinning around the nucleus. Remember, when we were looking at the atomic number stuff, it did say that the protons... What did I just write? Protons. Protons is the same number for the electrons. So the number of protons is equal to the number of electrons. So 1 proton, 1 electron. Okay. Now the mass number for hydrogen is 1.00794, but on the periodic table that we have, it just says 1. So we can just cross that out and say 1. But at the end of the day, it's 1.00794. We are just rounding it off basically to 1. And in this case, we have no neutrons because remember the neutrons in a nucleus is equal neutrons is equal to the mass number, and we know our mass number is 1, rounded of course, minus the atomic number, and the atomic number is also 1. So we have 0, and that means no neutrons. Nope. Okay, now we're going to look at carbon. The chemical symbol for that is C, and it does show you in here when you look at the little element thing. And when you look at C, it says 12 at the top and 6 at the bottom, and that means the mass number is 12. It's written the wrong way around, but it's okay. And the atomic number is 6, and then the symbol for the elements is C, and that's also the chemical symbol or just symbol for the element, anything like that, you'll understand. Okay. Now, if we look at the atomic number, which is 6, we know there's 6 protons and 6 electrons in carbon, okay? And we know that because there's an equal amount of protons and an equal amount of electrons in an element, okay? Now the mass number of carbon is 12, and we can then figure out the neutrons from that, and the way we do that is saying neutrons is equal to the mass number, which is 12, minus the atomic number, which is 6. So we know that the neutrons is 6 for carbon. And that's really easy, that's all we need to know. And also protons, 6 protons, if you look at this little diagram B here, there's 6 little electrons floating around the nucleus, okay? And electrons are little minuses. They have a negative charge on them. And then when we look at the nucleus, there is 6 positive, because protons, if you just think of it in a way like pro is a good thing, so it's a plus. So there's 6 pluses in the nucleus, which means it's 6 protons. Really simple. And then also within that nucleus, there's also going to be your neutrons, so there should be 6 of them. And it does say it over here. 6 protons and 6 neutrons in the nucleus and 6 electrons around the nucleus. Simple. Please take down all of the stuff that I have written on these slides into your books so you can do your homework and activities. Okay guys, so the next thing in the periodic table of elements is the arrangement of elements. So there's two main things that we need to remember, and that is just groups and periods. Now groups are the vertical columns numbered from 1 to 8 in the periodic table. So firstly, we are just going to work with 1, 2, we're going to name 13 to 18, 3 to 8, 4, 5, 6, 7, 8, and you should write this on your periodic table. It makes things a lot easier, just in terms of working in the future with this stuff. So groups are the vertical columns, so as you can see, it's everything going up to down, so it works like that, and that's for groups. And then it also says elements in the same groups behave in a similar way. They have the same chemical properties. And we'll get more into that in grade 10, but for now you can just know that elements in the same groups behave similarly. Okay, so for example, in group 1, we have potassium. So over here, potassium, sodium, which is Na, and lithium. Just redraw that, and lithium, which is Li, are all in the same group, which is group 1, and then hence they will react similarly. And that is okay to know because we did just say that elements in the same groups behave similarly, so we know that lithium, sodium, and potassium should behave in a similar way. Cool, so next thing, periods. They are the rows that run from left to right. So periods go like this and that. Periods. And there are 7 periods in the periodic table. If you count here from hydrogen, there's 1, 2, 3, 4, 5, 6, 7. And if you want to like refer to a certain element, like let's say we are looking at silicon over here, we can say that it is in period 3, so silicon is period 3 and group 4, or group 4 and period 3. Either way, you're just saying where this element is basically. So the atomic numbers of the elements increase as you go from left to right across the period. And if you look at, for example, hydrogen way at the top left, its atomic number is 1. And then if you look at, let's see, carbon, yeah, carbon's atomic number is 6. So that proves that the theory is correct. So let's see, hydrogen is 1, and going to carbon, it increases from 1 to 6. 6. Okay, and that's really simple. And then in the example, it says use the groups and periods to describe where calcium is in the periodic table. So calcium is in group 2, period 4. So if we look here again, group 2 is this group, and in period 4. So calcium is over there. And that's really easy, right? Because if you just label your periods and your groups, then you are fine. Cool. Next slide. Actually, not the next slide. Please do activity 2 and 3 on page 77 for homework, and you'll do those using these notes that you have taken down from these slides. Basically, activity 2 is just using the periodic table to understand elements, and then activity 3 is to study one element. It's really easy. Just use your periodic table and read the questions carefully. If you don't know what something in the question means, you can ask me, or you can look at the back of your book in the glossary for anything that is in the question. Like, let's say they ask you to write down the chemical equation or something like that, or what group is a certain element in. Just refer to your definitions again and you will know exactly what the question is asking you. If not, just do a classroom comment on Google Classroom. Hey guys, so we're back on the periodic table of elements once again, and we are doing the classification of elements today, and that means we are looking at metals, non-metals, and semi-metals. So if you just remember the activity 1 we did at the beginning of this whole PowerPoint, we did get a question of, is hydrogen and oxygen metals or non-metals? And I did refer to these definitions during the thing by talking about them. But anyway, now we're just going to go through them properly and we're going to see how we can remember what metals, non-metals, and semi-metals are by knowing their definitions or by knowing how to look for them in the periodic table. Cool. So metals are in the middle and the left side of the periodic table. So if you look at the periodic table, it says everything that is that weird peachy color is metals. And that's really simple. Like, it shows you the colors of everything and you will know then. But let's say you get a periodic table that doesn't have colors on it. Then you can just remember that metals are in the middle and the left side of the periodic table. So middle and left side, which is over here. I don't know why I'm circling it if it's already in color, but like, you know, it's as easy as that. And then of course all of these other metals at the bottom here. Well, all of the elements at the bottom here are metals too. Then it also tells us that all metals are solids at room temperature, and this is how you can remember what metals are. If you know the properties of a certain element or something, you know whether it's a solid or not at room temperature, and then you know that it's a metal if it's a solid at room temperature. The only exception is mercury, which is Hg, and it's over here on the periodic table, and that's the only one that is a liquid at room temperature. Please remember, room temperature means 25 degrees. This is very important. It just helps you with a lot of things in chemistry, basically. So non-metals, they are on the right side of the periodic table. I'm just gonna take its color, it's weird orangey yellow color. I'm just gonna circle them. So they are on the right side of the periodic table. Don't be fooled though, there's one non-metal that is not on the right side, and that is hydrogen. That's like kind of your exception for that one rule. Then it says most gases are, most non-metals are gases at room temperature. Room temperature, remember, is 25 degrees. Where's my pen? 25 degrees Celsius. Okay. But some of them are solids at room temperature. So in the example, it says literally only bromine, which is Br, and it is over here in the periodic table. I don't know if you can see that, but I just circled it a lot. That's the only liquid at room temperature. Cool, that's really easy, all on the right side of the periodic table except for hydrogen. Now semi-metals, the green color, is green. Let me just do this for my OCD brain. Yes, okay, so green. Semi-metals on either side of the black zigzag line on the periodic table. I'm pretty sure that most periodic tables that they give you will have the zigzag line, so it'll help you a lot with this, but let's just circle again. These are your semi-metals. Only a few of them, it's not a lot. So either side of the black zigzag line on the periodic table, they have properties of both metals and non-metals. So they can be solids at room temperature, gases, liquids, doesn't matter. It's similar properties, and I guess it will specify when you are working with any of these semi-metals. Cool. So that's basically that for the classification of elements. Hey guys, so the last slide for the periodic table of elements. This is the formula and compounds. So compounds are elements that are joined together. So if you look at the example for water, which is H2O, the compound is hydrogen and oxygen. So H2 and O2. Remember I said there needs to be a 2 on the H and the O because it's diatomic molecules. Okay. And then a formula shows the ratio of the number of each element in the compound. Use the symbols of the elements to write the formula for the compounds. So the formula, there's a ratio of 2 hydrogen atoms to 1 oxygen atom in H2O. But in the entire formula, remember it's at 2H2 plus O2 gives you 2H2O. Okay, because there's 4 hydrogens here now, because that little subscript 2 over here times the big 2 over here gives you 4. So we're just writing that at the top so we can show that this equation is balanced. Again, 2 hydrogens times the subscript 2 is 4. And then because the 2 is in the front here, it also times with the O, and there's only one O, so that means we're going to have 2 O's at the end of the day, and over here, here's 2 O's again. So this equation is balanced. But it's the equation, okay? And we know a chemical formula is basically from activity 1, if you remember. The chemical formula is literally just the H2O part of the whole situation. But the thing that I just wrote down over here is a chemical equation. So don't get that messed up. Just remember the equation or the formula part of the whole thing. Okay? And that's that for compounds and formula. Now please do activities. Sorry. 4 and 5. Activity 4 is just memorizing the first 20 elements of the periodic table, and activity 5 is using the periodic table of elements. Okay, and these are on page 79 and 80, so please go do your activities, and that's unit 1 done for you guys. Okay, if you need any help with the activities, once again, just send a little classroom comment on Google Classroom and I'll have a look at it. This should be easy for you guys, so good luck and enjoy. That's so far for this week. We're still gonna go through unit 2 though, for this week, and then your work's done for the week.